Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we are working together. Today is our lesson number 33. We are on page number 97. In the second column, you see there three problems, starting with 149. Problem number 149, as you can see, is already on the blackboard. Let's take a look at it. I'm going to read it to you, then I'm going to get out of the frame. You do it yourself, and then we'll compare the work that you did by yourself against the work that we'll do together. Okay? Here's the problem. It's a very straightforward, simple problem dealing with probabilities. It says that the probability that the event M will not occur is 0.8. We are further told that the probability that the event R will not occur is 0.6. We are also told that M and R cannot occur at the same time. If event M occurs, R cannot occur, and vice versa. Question simply is, what are the odds that either M or R will occur? Go ahead, do it yourself. So here's what's going on. Let me first explain to you in terms of Venn diagram, even though Venn diagram is not necessary here because it's very straightforward. Here's what's going on. If you have an event, let's say M, and another event R, this area that we see that overlaps represents the odds that both M and R will occur at the same time because it's a common area. It overlaps. Here we are told that they cannot occur at the same time. Therefore, what we are dealing with here are two disjointed sets. They do not overlap. This thing is zero. This entire thing is zero. So if they're zero, they do not touch each other, they do not overlap. And we are told that the odds that the event M will not occur is 0.8. That implies that the odds that the event M will occur is simply 20%. Similarly, the odds that R will not occur is 60%. Therefore, the odds that R will occur is simply 40%. And therefore, what are the odds that either this or that occurs? Is simply the sum of the two, is 60%. That's all. Now, in terms of the set theory, or rather, in terms of the Venn diagram theory, if you wanted to show it in terms of equation, this is how it's written. The odds that event M or R will occur has to equal the odds that M will occur plus the odds that the event R will occur, which is what we have so far here, M and R, minus the area that they overlap, which is the odds that M and R will occur at the same time. And this part is zero because they cannot occur at the same time. There is no overlap. Hence, it's just 0.2 plus 0.4 plus minus is zero. Minus is zero. And therefore it's just 60%. That's all. Before we go to the next problem, problem number 150, before we go to the next problem, let's do one more problem dealing with probability. So here's the new problem that is not in the book. Here's the problem. We're going to roll a dice. We're going to roll a dice, and the event A, we're describing event A as the odds of rolling a perfect square. I shouldn't have written so big because now I left no room for myself. And let's define event B as the odds of rolling a prime number. So the question now is, what are the odds that we either What are the odds that we either roll a number that happens to be a perfect square, or we roll a number that happens to be a prime number? Go ahead, do it yourself. So here's what's going on. I'm going to erase this roll part business so that we have the room. The odds of rolling a perfect square. Or odds of rolling a prime number. Let's find out how many different ways we can roll a perfect square when we roll a dice. A 1 is a perfect square. The next perfect square would be 4. We have 3, 4, 5, 6. That's it. That's about it. There's only 2 ways. There are only 2 ways. We either roll a 1 or a 4. Those are only 2 ways we can roll a perfect square. The odds of this event, the odds of event A, is simply 2 out of 6. Let's look at how many different ways we can roll a prime number. You mustn't forget that the 2 is a prime number. 2 is the only even number that qualifies as a prime number, because the definition of a prime number is that it is a number that can only be divided by itself or 1. And the only way we can divide 2 evenly is by itself or 1. Therefore 2 is a prime number. The next prime number is going to be 3. Next prime number 4 is not a prime number. Next one is 5. There are 3 ways we can roll a prime number out of 6. And now we can clearly see that these 2 also happen to be disjointed sets. If you were to show them in Venn diagram, nothing will appear in the common area. Here's event A, and here is event B. In event A we have a 1 and a 4, and here we have a 2, a 3, and a 5. Nothing overlaps. These are disjointed sets. Therefore, the odds that either this or that will happen, there are 2 ways of rolling this guy, perfect square, there are 3 ways of rolling a prime number. Therefore, the answer here is 5 out of 6. 5 out of 6. You technically it should be, well, I'm making the point. That's what it is. You understand? 5 out of 6. You're practically guaranteed that you'll either get a prime number or a perfect square, because the odds of not rolling a perfect square or a prime number is only 1 out of 6. Let's do the next one, 150. And that 1 out of 6 is if you happen to roll a 6. 6 is neither a perfect square nor a prime number. Number 150. We are told that the total cost is made up of fixed cost and a variable cost. We are told the total cost of doing something here, whatever it is that they're describing, whatever it is that the question is describing that we're doing, it's not necessary for us to know. The point here is that we need to spend $10,000 to produce whatever it is that we're about to produce. We want to make something. In order to make something, you have to have capital, you have to have machines. It costs $10,000 to do whatever it is that we're about to do. The variable cost, we are told, is $3 per unit. That's the variable cost. We are further told that when we finish making it, we can obviously sell it. Sell it for $8 per unit. And we are further told that we sold 20,000 units. Here's the question. The question is, as a result of having sold 20,000 of these units, how much profit were we making per unit on average? Do you understand? Go ahead, do it yourself. So let's find out, shall we? So in order to figure out the profit per unit, we have to first figure out the gross profit. And the gross profit is simply the gross profit is simply total cost, or rather total revenue minus the total cost. Let's find out the total cost first. The total cost is $10,000 that we told that we need to spend up front to buy the equipment, and then we are told that once we start making these things, it costs us $3 to make each of these units, and we made 20,000 of them. We made 20,000 of them, which means each of them cost $3 to make it, so we spent $60,000. Our total cost is $70,000. Our revenue, we sold them for $8 per unit, and we sold 20,000 units. There you go. As you can see, the units are going to drop out. So it's 160. That's it, we're done. 160 minus 70, that gives us a gross profit of $90,000. And we are told that we sold 20,000 units. So that represents the profit per unit. We have a total gross profit of $90,000, total revenue of 160 minus the total cost of 70, that's $90,000. We sold 20,000 of them. As you can see, 1,000 drops out, zeros are going to drop out, and it looks like we made $4.50 per unit in profit. Profit per unit is $4.50. Let's do the next one. 151. 151, the very last one on the problem on that page. Before I write down the problem, 151, before I write down the problem on the blackboard, let me first give you the answers. Q minus 1 over 2 plus 120. Q over 2 plus 119. Q over 2 plus 120. Q plus 119 over 2 over Q plus 120 over 2. Those are the answer choices. Here's the question. 151. We are told that Q is an odd number. The question is this: the median of Q consecutive integer is 120. The median of the Q consecutive integer is 120. Here's the question. The question is, what is the largest of these integers? Go ahead, do it yourself. Let's do it together, shall we? Well, instead of doing it theoretically and algebraically and taking a chance of messing it up, the simplest, the quickest, the most economical way here is to make up a number for Q. We are told that Q is an odd number. Since Q is an odd number, you could make the Q as small as 3. Let's make it 5, or better yet, let's make it 7 just to see what's going on. We're going to pretend the Q is 7. If Q is 7, now the question reads, the median of 7 consecutive number is 120. There we go. That makes it more concrete. Let's take a look at it. And we just have to figure out the largest one. So we have seven consecutive numbers, and we are interested in finding the median. So here are the 7 numbers. 1, 2, 3, 4. That's the median. 5, 6 and 7 because there are 7 of them. We already know that this is 120. The question is, if this is median is 120 and we have 7 of them, how many are here on this side? 3 of them obviously. 3 on this side, 3 on that side. We have to represent this quantity of 3 using the symbol Q. So listen carefully. Since we have 7 of them, and one of those 7 is right here, that's sitting in the middle, median. The one is already there, which means we only have Q minus 1 left over, which makes sense. One of them sitting here, which means we have 6 of them left over. 3 on this side, 3 on this side. This is 6. Q minus 1 is 6. Half of those are sitting on this side. Half of those are sitting on this side. There we go. 3 of them are sitting there, which means if 120 is the median, okay, here we go. If 120 is the median, if he has 7 consecutive numbers, and 120 happens to be the median, if he has 7 of them, and 120 happens to be the middle one, then the largest one is going to be 121, 122, and 123, which is simply 120 plus 3 obviously, and that is 3. Therefore, median simply equals 120 plus this quantity. That's our median. Right there is the answer. Of all the answer choices that you saw on the blackboard, that is the answer. I don't know which answer choice it was. I erased everything, but that's the answer. That was number 151. That happens to be the very last problem on the page. So we're going to stop right here. We're not going to start a new page. We'll meet again tomorrow, and we're going to pick up from the next page, page number 98. Okay? Bye now.